Welcome back. We are in lesson 33 of Algebra 1. We're going to talk about products of prime factors. So a factor is prime when you cannot multiply any other number to get that as a result or as a product except for itself and 1. So for instance, 2 is a prime number because the only thing we can multiply to get 2 is 1 times 2. Right? 5 is a prime number because the only thing we can multiply to get 5 is 1 times 5. So the only thing you can multiply to get a number is 1 times that number, it's prime. So prime factorization means that we want to factor a number all the way down into prime numbers. So for instance, if we wanted to factor 80, not 80, let's do another number. Let's do 75. If we want to factor 75, first thing I like to do is start at the smaller prime numbers. And our prime numbers to start with for this are 2, 3, 5 is a prime number, 7 is a prime number, 11's a prime number, 13, 14's not, 15's not, 16's not, 17, 19, 23, and I think there may be some more, but I can't think of them right now. 29. I think 29 is a prime number. 31. So they get fewer and fewer between the further up you go. But make a little list. Write it on the back cover of your notebook or somewhere handy of the numbers to start with. And then work your way through them. So the first thing I ask myself, is 75 divisible by 2? No, it's not. Is 75 divisible by 3? Yes, it is. 75 is 3 times 25. And 3 is a prime number, so I can move on to this number. Is 25 divisible by 2? No. Divisible by 3? No. Divisible by 5? Yes. 5 times 5 is 25. These are prime numbers. So therefore, that's as far as I can go because I have no other numbers to divide out. So the prime factorization of 75 is 3 times 5 times 5. And you could also write that as 3 times 5 squared because we use 2 5s in our prime factorization. Okay? So that is how you would factor a number to its prime factorization. You start at the lowest prime numbers and work your way up until you have it broken down as small as possible. All right, so let's do 33.1. We're going to factor 80 into prime factorization. So starting with 80, let's think about our first prime number, 2. All right, 80 divided by 2, that's 2 times 40. Okay, let's factor 40. That's going to be 2 times 20. All right, that's prime, so let's factor this one. 2 times 10, that's prime, so let's factor this one. 2 times 5. Both of these are prime numbers, so that's as far as we can go. So 80 is prime factorization is 2 times 2 times 2. See, 1, 2, 3, 4 2's and a 5. And you could also write that as 2 to the 4th times 5. Because we have 1, 2, 3, 4 2's. All right, let's do 33.2 and we are going to factor 147. All right, so let's start with 2. Can we factor this by 2? No, we cannot. 147 is not divisible by 2. What about 3? Can we divide it by 3? Yes, we can. 3 times 49. All right, so that's awesome. So now let's factor 49. What times what gives us 49? 7 times 7. 7 and 7 are both prime. So that's as far as we can go. So 147, the prime factorization is 3 times 7 times 7, or we can write that as 3 times 7 squared because we only have 2 7s here. All right? All right, easy peasy. So let's move on to word problems with unequal quantities. Let's clear the page. Sometimes a word problem makes a statement about quantities that differ by a specific amount. So the statement tells us the quantities are not equal, and our job is to write an equation that makes the quantities equal, that levels them out. So here's an example. 33.3. I am going to pause and type it because this takes a while. So we went ahead and wrote 33.4 down as well to save a little time. So let's look at this one. We are told that twice a number is 42 less than negative 102 or 102. So to me, here's how I would solve this. I look for my equal sign first. So here's my equal sign, that's equal. So I look over to my left and I say twice a number, that's 2n, is 42 less. So that means I'm going to be taking 42 away from this here, from whatever this is. It's 42 less than this number. So all I need to do now is solve it. So I say 2n is negative 144. I divide both sides by 2. And n is equal to negative 72. That's not so hard. I think we can do these. So let's look down here at 33.4. Let's look for our equal sign is, and now let's look for this side. Let's put our equal sign in. 5 times a number is 72 greater. So we're going to be adding 72. Then the opposite of the number. Oh, I got a misspelled word there. That's terrible. All right, 72 greater, that means plus. Then the opposite of the number. So the opposite of the number plus 72 is equal to 5n. So now we just have to do the math. So I'm going to add n. That's 1n, 1n. Remember, when you have a variable by itself, there's always a 1 in front of it. So we're going to add 1n to both sides. We get 6n is equal to 72. When we divide both sides by 6, we find that n is equal to 12. Easy peasy. It's really all about finding that equal sign and knowing how to balance the scale, knowing how to take this number and move it to the back with the appropriate sign. So 72 greater means we're going to add 72, 72 more, right? 42 less means we're going to take away 42, so that's a subtraction. All right, let's try 33.5. Let's do it here. And do we have, yes, we have 33.6. So I'm going to type those both here for us. All right, so 33.5 is just a little bit trickier than the others. And the reason I say that is because it has is in here multiple times. So we have to figure out which is the equal sign. So let's read. If the sum of twice a number and negative 14 is multiplied by 2, okay, I don't see a then or something like that. So this can't be the first bit. This can't be the where the equal sign is. Here, it can't be. It goes on to say the result. Okay, if it says the result, that's a big fat signal that says equal. So that's your equal sign. The result is, look at that. I forgot to type it all. It should be, let me erase this. The result is 12 greater than the opposite of the number. So Miss Tracy's typing could use a little bit of work. I thought that didn't look right. But the result is your equal sign. The result is 12 greater, so we're going to add 12, than the opposite of the number. So the opposite of the number is this. It's negative n. So 12 greater than the opposite of the number. All right, so let's work on this side. If the sum, so we got two things going to be added together, of twice a number, okay, that's 2n, and negative 14, so the sum of those is multiplied by 2. The result is 12 greater than the opposite of the number. Okay, that looks right. So let's do some distribution here. 4n minus 28 equals negative n plus 12. All right, let's add n both sides. Remember, that's 1. And then let's add 28 to both sides. So it's 5n equals 40. So n is equal to 8. Now the way we can check that to make sure that we got the right answer is to take n, take the value of 8 and substitute it back in for n in our problem. So let's check our work and see if that really is true. So 2, let's drop 2 times 8 in here, minus 14 equals negative 8 plus 12. So let's see if that's true. 2 times 16 minus 14 equals negative 8. Well, negative 8 plus 12, we can go ahead and solve that. Negative 8 plus 12 is 4, positive 4. All right, 16 minus 14, that's going to be 2. 2 times 2, 4 equals 4. So that is correct. We did it correctly because we were able to take this answer for n and substitute it back into our original equation, and we got the same number on both sides, which means it balances and the equation is true. And you can do that for any of these. If you want to check your work, if you're not sure that you got the right answer, just take the result and drop it back in and substitute it back in and solve each side of the problem, and if it balances, you did it right. All right, let's do the last one. 5 times a number is, I don't see any other is's, so this has to be our equal sign. Okay, 5 times the number, that's 5n, is 21 less, so it's going to be minus 21 somewhere. 21 less than twice the opposite of the number. Okay, so twice the opposite of the number is that. Let's distribute. 5n equals 2 times, remember there's a 1 right there, 2 times negative 1n is going to be negative 2n minus 21. All right, let's add 2n to both sides. So this is going to be 7n equals negative 21. We divide both sides by 7. N is equal to negative 3. Okay. Sorry, I didn't write that out. We divide both sides by 7. Then n is equal to negative 3. And let's check it. Let's just make sure. So 5 times negative 3 equals 2 times a negative 3 minus 21. All right, that's negative 15 right there. Okay, negative of a negative 3, that's going to be 2 times positive 3 minus 21. That's going to be 6. 6, positive 6 and a negative 21 is a negative 15. So it balances, so this is the correct answer. All right. Okay, if you guys have any questions, please feel free to ask. That's what I'm here for. And I'll see you in lesson 34. And while you're at it, if you'll click like and subscribe to these videos, then it'll make it more readily available and easier to find for other people that need math help. See you later.